Oh, it's a 1 mark question.
So we are getting zero now.
So when the radiation pressure balances with the gravitational force, so the star will be a stable star. No, no, no. The second part is okay. Like the last part is correct. Yeah, you will score the mark for one. Let me discuss. I will come to me. Just keep it here so I will remember. Yeah. Define the Hubble constant. What is the Hubble's constant?
The distance increases. Yeah.
Hubble's constant, yeah.
The distance is increasing. The space is expanding.
Someone. Yes, Ayan, what's your answer?
Hubble constant is rate of expansion of universe. It helps to measure speed galaxies move away from Earth.
Okay. Anyone else want to add?
The distance is increasing because the space is expanding.
Look, what is the Hubble's law?
Then he's looking from the
Hubble's law states that the recession speed of the galaxy is directly proportional to distance of the galaxy. Or we have the formula that V is equals to H naught D, or V over D is equals to H naught. So what is a Hubble's constant? Hubble's constant is actually a ratio between the recession speed, the speed at which the galaxy is moving away, and the distance of the galaxy. Yeah, recession.
Then I was searching on Google, nothing was coming. What was this?
So the Hubble constant, define the Hubble constant. It's a ratio between the speed and yeah, 1 mark is for speed, 1 mark is for distance of a galaxy. But mention recession speed or the speed at which the galaxy is moving away.
Genuinely मैंने ये लिखा जैसे नहीं आता
And the distance of the galaxy. The current estimate for the Hubble's constant is 2.2 into 10 to the power minus 8 second inverse. State the equation which gives the estimate age of the universe. So if we want the age of the universe is always reciprocal of the Hubble's constant, 1 over h naught. And then estimate. State equation they mention here, so you can write symbolic or a word, it's fine. Or you can also write the age of the universe. The estimate the age of the universe. So the age of universe is reciprocal of the Hubble constant. So it will be 1 divided by 2.2 into 10 to the power minus 18. So we got how much?
4.55 10 power 17.
So 4.55 into 10 to the power minus 17. That is,
Positive 7.
sorry, negative will be very small. Positive 17. Yeah. Yeah, negative means like 0.0000.
Sir, they called you sir negative.
open this. He has the answers. That's why I'm not calculating. Because you have the answers. After all this, you will say the answer easily.
Draw a circuit diagram for a potential divider.
Yes, finally something I studied.
Potential divider.
Let's see. For
It's
goodness
a
sake.
straight circuit, I guess.
This is a potential divider circuit.
No, one of them are-
Symbol for potential divider.
Why is it?
That's
What do we do? Like,
That is a thermistor.
Sir,
Figure 7.1. Yes, arrow up or down. No, no. It should be vertical. Yeah, this is okay. This is also correct. Yeah, it's fine. No, this is also fine.
Sir, I have a question.
In part A, we want a circuit symbol for a potential divider circuit. So what is a potential divider circuit? A rectangular box. If you draw an arrow in this manner, that's fine. If you make an arrow like this, that's also fine. If you draw an arrow like this, that's also fine. It's acceptable. The thing is 2 fixed ends and 1 movable or a sliding contact. Yes, what's your question?
What was the function of the arrow?
Changing the resistance, so dividing the voltage. Figure 7.1 shows a circuit. Calculate the value output. So we use a potential divider formula. What is the potential divider formula? If I need the voltage here, so I'll use a resistance of that part which is 1, because in a potential divider formula, the resistance of that part which is 1 divided by the sum of the resistance, this is 3 kilo ohm. So what is the sum of the resistance? 1 plus 3 into total voltage. What is the total voltage? 6. So this will be 1 divided by 4 into 6. So it will be 6 by 4, which is equals to 1.5 volts. So whenever you see a variable, 2 or more resistors are there connected in series, we call them as a potential divider circuit. So in a potential divider circuit, if I need the voltage across the first one, and this is having resistance R1 and this resistance R2, so resistance of that component divided by the sum of the resistance multiplied by total voltage. If I need the voltage across the second one, resistance of that part divided by the sum of the resistance into total voltage V. This is
The one is R out.
which one?
The one is resistance.
This is first resistor, this is second
Sir,
resistor.
I understand the question, but why did they write in the diagram 1.0 and the question 3.0? Why did it?
No, this is 3.0
Yeah, and
because this is a variable resistor.
yeah, why did they write it?
This is a variable, this is a fixed resistor which has 1 kilo ohm, and this R in the question, the R having a value of 3.0
Yeah, why
kilo.
did they write it in the diagram?
Because it's a variable resistor, so its resistance can be changed. At this position, it has a resistance of 3. But its resistance is not constant, it can be changed as we move the sliding contact.
So they are not trying to confuse me.
Yes, because otherwise if they wrote here that this is 3.0 or 3 kilo ohm, then it means that it is a fixed resistor. Its resistance is constant. But because its resistance can be changed, that's why they did not list on the diagram.
It can be changed.
It can be any number, yeah.
So they can give it and say that it's a very good resistor.
Next is the value of R is adjusted until the current in the circuit is 1.7 milliampere. The total charge that flow through the circuit. So current is charge divided by time. So if you need the charge, it is a current multiplied by time. For electricity, the most important thing is memorizing all the formulas. So 1.7 into 10 to the power minus 3, that is milli, multiplied by 300. What's the answer?
0.51.
0.51 and the unit is coulomb. Define specific heat capacity. The definition of specific heat capacity. No, latent heat is removed. Specific heat is still part.
Heat required to.
Specific heat is energy required to change the temperature of 1 kilogram substance by 1 degree centigrade. So you have to learn the definition. The PDF I have already shared about the definition. Learned all the definitions. Next is the volume of a 0.0024 meter cube of oil is heated for 7 minutes. The temperature increases from 20 to 180. The density is 910. The specific heat of the oil is 2000. We need the mass. How to work out the mass? Density is mass over volume.
So
So if you need mass, density times volume. The density is 910, 0.0024. What's the answer?
2.184 kg.
So 2 point,
2.2 kg.
2.184.
2.18 kg we can write.
Round off here.
Okay. Then calculate the increase. If you need the increase in energy, that is the specific heat into mass into temperature change. The specific heat of the oil is given for 2000. The mass of the oil, which we calculated in the previous part, that is 2.18 or 2.2. And the temperature change here, it started from 20 and ending at 180. So the temperature change is 160.
69.76.
69.
69.76.
Rounded off to 700,000.
Repeat, sorry.
69.76 and 00.
Here, number 69,000.
6.976 multiplied to the power of 5.
697,600.
rounded off.
So 6.9, say, yes, 10 to the power 5, right.
That
The
gets
last we need the power. What we just